Ah, there you are. It's Mr. Obi from GCSE Physics Explained. I'm going to teach you about electromagnetism. Learning objectives. An electric current flowing through a wire causes a magnetic field around the wire. Know the factors that affect the strength of the magnetic field around the wire. Know how to draw the magnetic field pattern for a straight wire carrying a current. Electricity and magnetism are connected. If you've got electricity, you can create magnetism, and if you've got magnetism, you can create electricity. Watch. This is a galvanometer which measures current, electrical current. Here's a coil of wire. If I take this magnet and pop it inside that coil of wire, it'll create electricity. So this is magnetism creating electricity. As you can see from the dial, when I move the magnet in or out, it creates an electric current. So that's an example of how magnetism creates electricity. Now I'll show you some examples of how electricity can create magnetism. It was discovered that if you allow an electric current to flow through a wire, then a magnetic field gets set up around the wire. So what I've got here is a power pack. Now at the moment, there's no current flowing through this wire. Now I hope you know the difference between conventional current and actual electron flow. So conventional current comes from the positive terminal of the battery, and it flows through, so it would flow through this red wire here, and it would flow through there, it would flow up here, across there, down there, and out the black wire, and back to the power pack. Now at the moment you can see that I haven't got the power pack switched on. And you can see that all of these plotting compasses, which show us a magnetic field, they're all pointing in the same direction. They're all pointing this way, which is north. Now they're aligned at the moment with the Earth's magnetic field. However, once I turn this power pack on, the current will start to flow through this wire, and it will have its own magnetic field. And because this wire is a lot closer than the north and south pole of the Earth, these plotting compasses will align with the wire's magnetic field rather than the Earth's magnetic field. So let's have a little look at that. As I turn this on, keep an eye on these plotting compasses. And there we go. You can see that they've changed direction there. Now, in order to tell which direction the magnetic field is, we use the right hand grip rule, okay? Your thumb shows you the direction of the current, and your fingers show you the direction of the magnetic field. Your thumb shows you the direction of the current, and your fingers show you the direction of the magnetic field. So, as I said, conventional current. We've got the current coming out of the positive terminal of the battery, and the current's coming all the way through these red wires, and it's getting down to this bit, and then the current is coming up here. So if we align our thumb going upwards, what that means is the magnetic field, which always travels from north to south. Your knuckles are the north, and your fingertips are the south. So the magnetic field, if we look downwards, is going anti-clockwise. Now if we look at those compasses, you can see that they're all going anti-clockwise. So that's correct. Now here's the thing, if the current's coming up this side of the wire and coming across here, that means it's going down that side of the wire. So again, if we use the right hand grip rule, the current will be moving down that wire there. And so if we have a look at our hand, our fingers, they show that the magnetic field is moving in a clockwise direction. So if I move these compasses over to here, and if I turn this power pack back on, 1, 2, 3, and there we go. So you can see that the magnetic field is moving this way. And that's because the current is moving downwards. Okay, so the plotting compasses, they show us the direction of the magnetic field, but if you need to see the shape of the magnetic field, then we use iron filings. And all we do is we just sprinkle the iron filings around the wire. If I just turn the current up a bit, just give these a gentle nudge, what you can see is they're starting to go around in a circle. Can you see them going round in a circle? Round and round in a circle. It's not the clearest, but you can see it is happening. So the direction of the magnetic field is shown by the plotting compasses, and the shape of the magnetic field can be shown by iron filings. An advantage of an electromagnet compared to a normal magnet is that you can turn the magnetism on and off just as simply as you can turn the current on and off. So at the minute that wire is not magnetic because the current's not flowing. As soon as I turn the current on, you can see the wires became magnetised. Turn it off and the compasses realign themselves with the Earth's magnetic field. And if you make the current bigger, you can also turn it into a stronger magnet. Just turn the voltage up to 10 volts, which means that the current's getting bigger as well. Watch how fast the compasses move now compared to before. You can see that they're moving faster. Want to see more videos like this? Subscribe to my channel, GCSE Physics Explained. Thanks very much, and bye for now.